You're watching NASA's 2026 Lunabotics Finals event, streaming live from NASA's Kennedy Space Center Visitor Complex. The Iowa State University robot has just started its second and final competition run of this competition. And this is the last of our 10 teams to compete. So you were watching the last run of our event this year. This robot presumably just did, yeah, I just saw the student pick up the joystick. That was an automated dig event, and now I think, so the students probably got credit for that automated dig, and now they may be probably doing a manual dig. So the students will get extra points for having some automation there. And each team chooses what parts of their operation they want to perform autonomously and what portions they want to just maximize their throughput and just drive as hard as they can in order to maximize the amount of material that they deliver. This team, when you see a robot stop like that, sometimes they're configuring something or about to activate a new mode. For example, an automated traversal, which is what I think is happening right now. The student hit a button and then put the joystick down, and then the robot started spinning. So this spinning is usually an indication of a mapping routine. The robot's sensor needs to, oh, okay, that was a little worrisome. I thought it was going to hit the wall. The robot needs to show its sensor to the entire arena in order to map it out. And it looks like the students took over control because the robot was hitting a rock there. So this is a manual drive. Are they going to drive over those rocks just like that other team did? Or are they resetting in order to try another? Nope, all of that effort was just to turn this robot around. It's a pretty big robot, and just needed a big space to turn around. No, I think they're going to set up for another autonomous traversal. Even though this is going to eat up some precious time, if it succeeds, the autonomy points are going to be worth the effort. All right, I think the students are just stick driving it because too much time was being wasted on their autonomy attempt. So the robot needs to back in to the scoring zone in order to be in the correct spot. Okay, I think they're setting up for an autonomous delivery. Yeah, the student is showing the joystick to the judge, hitting a button, and then putting the joystick down. That's what just happened. So this is autonomous. Students are getting some bonus points for doing this operation hands-free. So 5 minutes has expired. What I expect will likely happens a lot for a lot of teams, is that they try a couple things in autonomy to get those points, and then the rest of their time is spent running manually because their production rates are so much higher when they're running in manual mode. And yes, the student is holding the joystick still, so this is very likely a manual dig operation. This robot lowers its bucket ladder digging system into the soil and then drives forward in order to dig fairly wide, and that's a couple inches deep, I would say, trench. That is a respectable trench. Now later, if this robot gets one of its tracks in that trench, hopefully that doesn't cause them any problems driving. I would say they have quite a bit. It's really hard to see because of the covers on this robot, but I would say that this Iowa State robot has a lot of material on board right now. We'll get to see how large of a pile gets deposited right here. Again, this appears to be manual driving. That's a nice big pile there. All right, so that only took 2 minutes, what we just saw. So if they do that 6 more times in the last 12 minutes, they will, I think, be really happy with their score. So they started way back against this wall, and they're driving towards the opposite wall, basically using almost the entire length of the digging zone. Okay, they're crossing over their old trench. I wonder how that's going to work with the productivity and the tracks dropping into the old trench right about now. That's going to make their digger go deeper. And so they raised up a little bit and compensated. So that didn't cause any problems with this robot. It didn't look like. There's some big rocks that they just brought up to the surface just then. This robot is not turning around in the middle of its run. It's digging on the front end of the robot and dumping from the rear end of the robot and making just a single arc between the two, not having to waste time to turn around. And it appears to be working for them. 11 minutes left. So at 2 minutes per cycle, okay, they're turning the robot around. They're starting in the opposite side. Spent a little bit of time to turn the robot around. Now they're going to drive in the opposite, dig in the opposite direction than they did earlier. Now they're going downhill, which means their digger's probably going to get a little deeper. I think that's the depth that they are wanting. Now that it's not going downhill, they might have to adjust the height of their digger a little bit. You can see it pushing rocks that are just not sized to fit in their system. If they didn't push those rocks out of the way, I fear that they might jam up this system. Oh, they're digging some more. They're not full yet. This team appears to be maximizing their onboard hopper because they could have gone and delivered just then. Okay, so now the robot is turned around, only having to do a 90-degree turn, not a 180-degree turn, in order to face the direction needed for depositing this material into the scoring zone. That is a lot of material. That is a lot of material. '90-degree turn. Another 90-degree turn. You can see they're taking a slightly different path than they had earlier. They're crisscrossing their own digging path. Explicitly not digging in the exact same trench more than once. All right, are they full? Nope, they're gonna dig some more. Just need a hair more on board, I think. 7.5 minutes remain. Oh, ooh, 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 ooh. We had a failure of their, their digging system got caught up in something and did some damage. Let's focus on depositing this material into the scoring zone with just under 7 minutes remaining, and then we can focus on the digger. That looked like a really bad day for that digger, though. Oh, I wish I had another camera angle. Oh, man. I think they're going for it. I think it was, they do have some buckets that are torn up, and they were getting caught in the pieces parts that are covering their bucket ladder system. I think they're just trying to tear away that plastic and that red fabric to get to a point where they can just have a free bucket ladder system. But I believe some of the buckets have torn off and are probably clogging up the works. That was a valiant effort, though, to just go for it and just rip off whatever rips off. And if it still works, then go for it. It appears, though, that in going for ripping things off, some things got damaged that may be unrecoverable. You can see how many buckets have been ripped off just on the front of this robot, and then ones that are on the other side of the conveyor belt are probably jamming up the works and keeping this robot from being able to move. Yeah, it looks like the students decided to just call it because there's no way to recover from this. Camera 4 has another angle. Of the damage. You can see that belt is actually in an area that maybe it shouldn't be in. Buckets are jammed and squished and squeezed, and I really do appreciate the effort that the students took to just run it at full speed and see if they could rip off the stuff that was in the way and continue. So after all of that, camera 1 has a side view of the berm that this Iowa State team has created. Kind of in the upper right, you can see how big that berm is that they created. I'm going to say it out loud. That is a big berm. So I'm just going to say it. Even though this team had this failure and lost, what did they lose? Like 5 minutes out of their event. I'm going to say they should still have hope. This berm they created is impressive. So I hope the students are not too sad or mad about what happened to the robot in that event. They should feel very proud of what the robot accomplished in, 15 minutes? Because they still had 5 minutes left on that 20-minute run when that failure happened. So I feel like this Iowa State team should feel very proud, and I don't know. I'm going to be interested to find out where they end up in the scoring, because I'm impressed with this berm, even with the short period of time that they were able to operate. All right, with that Iowa State event complete, let's give Iowa State a big round of applause. What a great effort on their final run. They had a bad failure. I mean a blowout. that was an amazing thing to see that robot tear itself apart there at the end. But man, that team should feel really good about what they just did.